Good day students, I am Somasundaram from Bharathidhasanar, Matric, Higher Secondary School, Arakkonam. I am very much delighted to help you out with hydroxy compounds. So, today the chapter is hydroxy compounds and ethers. So, we have been discussing about how to prepare alcohols from various other functional groups. Now, our aim is to prepare the diol as well as a triol. So, first one is a diol. Glycerol is actually an example for a diol. Okay. So, I am going to prepare a diol. So, what is the best method or what is the best reagent or what is the best reacting material to produce a glycerol? Here we are going to use a alkene. It is a very easy methodology to prepare glycerol. So, I am going to use a alkene. So, I will take a simple alkene, that is ethene. CH2 double bond CH2. So, next question, what is the reagent should be used to prepare diol here? Yes, that is nothing but Bayer's reagent. What is Bayer's reagent? There is nothing but alkaline cold K1O4. Why we are using alkaline cold K1O4? Generally K1O4 is a very good oxidizing agent. The compound has very powerful oxidizing property. So, if you use this K1O4 in room temperature, what happens? It will oxidize alcohol into acid. That is why we need to take the K1O4 in colder system. Okay. So, alkaline cold K1O4 should be used here. K1O4 with alkaline. It can be alternatively written as OH minus, which refers alkaline K1O4, and it must be cold. So, what happens with the alkene when you use alkaline K1O4? It introduces two OH groups with each of the carbon having double bond. So, the product is very simple, CH2 single bond CS2. Why? One double bond is broken, and in each of the carbon we need to add OH. That's it. So, in this way we can prepare a diol. Now students, I am going to explain the same kind of reaction with different initial reactants. The first one is with cyclohexene. Here we have a double bond between two carbon system which is available inside the ring. So, when you use it with alkaline K1O4, alkaline K1O4, and the system must be cold. So, what is the process? You have to write the molecule without the double bond and then add two OHs in the double bond where the double bond was there. Okay. So, I have added two OH here. Why? The double bond was there here only. So, that is why we have added two OH. What is the compound name? This is cyclohexene 1,2-diol. Why I am using 1,2-diol? We have two OH groups. That is why I am using diol. And wherever you use di, tri like that, you should put the number. Okay. So, the numbering is here I am giving 1 and the next carbon should be 2. So, 1,2-diol. This is the name. Okay. Next is how to prepare a triol, that is glycerol. So, glycerol, it is a triol. Okay. In this we have to add 3 OH groups. So, it is not easy to add 3 OH group. But fortunately, we have a generally available source that has 3 OH groups, that can provide 3 OH groups. That is nothing but triglyceride. So what is that? CH2, CH2, CH, CH2. So I am writing a fatty acid. This fatty acid, we have a ester. See, double bond O, CH2, 14 times. Number of carbon here, it is in a linear chain which has 14 carbons as a CH2. And then we have a CH3 at the end of the chain. The same system is here. O, C double bond O, the CH2, 14 number of carbon. At the end we have a CH3. Likewise here also, O, C double bond O, the same system, CH2, 14 times, and finally we have a CH3 group. This is known as a triglyceride. In this compound, it is available as a fatty acid, okay, fatty esters. Next, we are going to hydrolyze it using sodium hydroxide, NaOH. What is the product here? Whenever you hydrolyze with the sodium hydroxide, it requires some water. Anyway, sodium hydroxide has been taken in an aqueous solution. So it will be having some water also. What is happening? Here, ester is broken into alcohol and corresponding acid. So where is the breaking is happening? Here. Here the breaking is happening and you are getting the corresponding alcohol. What are they? In each breaking, you have to add OH group. So the product is CH2, OH, and then the center carbon has only one hydrogen, CHOH, CH2OH. Okay, this is triol. What about the byproduct? Yes, the byproduct is a acid. That is nothing but CH3, CH2, 14 times, and then COOH. This is known as palmitic acid. Palmitic acid. The compound here we are seeing as a triol is known as glycerol, okay, or propane 1,2,3 triol. I'll write the name. Propane 1,2,3 triol. Next, thank you very much students. In this video, we have discussed how to prepare a diol as well as a triol. A diol, glycol is an example. For a triol, glycerol is an example. Okay, so we have prepared these two compounds. Thank you very much.